Hello all, welcome to JSM. Here in this session we are going to discuss about previous JEE questions of the topic dimension analysis. Here comes the first question. Consider the equation h is equals to x to the power of p epsilon power q e to the power of r by t to the power of s. If you look at the dimensions of the given physical quantities, magnetic field intensity AL minus 1, electric field ML minus 3 A minus 1, and permittivity M minus 1 L minus 3 T4 A2, x distance L t time t. So we have to find the values of p, q, r and s respectively. For that, h a l minus 1 which is equals to x to the power of p, that is L to the power of p, and next permittivity m minus 1 L minus 3 T4 A2 all to the power of q, and next electric field intensity or electric field m L t minus 3 A minus 1 all to the power of r, and in the denominator t to the power of s is there, we comes to numerator, so t power minus s. After writing this, we need to check m, l, t, a on both sides. Here a and l minus 1 there, we don't have m and l, so for that I am writing like this: m0 l minus 1 t power 0 and a power 1 is equals to, in the RHS side, m minus 1 into q, so that will become m minus q plus m power 1 into r, so plus r. Next L to the power of p minus 3q plus r, so p minus 3q plus r, and next t, so t power 4 into q, so t power 4q minus 3r and minus s, and last we have a, so here a to the power of 2q minus 1 into r, it will be minus r. So after writing this, we have to just equate the powers. So equating powers of m, l, t and a. So for this, in the LHS side, m power 0 there, in the RHS minus q plus r. So 0 is equals to minus q plus r, then r is equals to q. Let it be equation number 1. And next L power minus 1 in the LHS minus 1 is equals to RHS p minus 3q plus r. So from the first equation we have r is equals to q. Just substitute into this, minus 1 is equals to p minus 3r plus r. It will become 2r minus 1 is equals to p. Let it be equation number 2. And next t power 0 in the LHS 0 is equals to, in the RHS, 4q minus 3r minus s. So it will become, from the first equation, r is equals to q, substitute here, 0 is equals to 4r minus 3r minus s. So r is equal to s from this. So first equation is r is equal to q. Here it will be equation number 3. So from first and 3 we can say r is equals to q is equals to s. Let it be equation number 4. Next, if you solve for the next one, a power 1 in the LHS, so 1 is equals to RHS 2q minus r. So 1 is equals to, from this equation or from that equation we can say 2r minus r. So r is equals to 1. So if you look at the fourth equation, r equal to q equal to s, here r is equals to 1, we can say r, q, s values are 1. So from the options r, q, s, only first option matches, even though if you want to solve p, so from second equation we can say p, what is p equation, sir? 2r minus 1 is equals to p. So in this we can see r value we got 1 here, so 2 into 1 minus 1 is equals to p, so p is equals to 1. So from the options we can say p, q, r, s values are 1. So first equation, first option will be matching. If you see the practice question, the potential energy of a particle changes with the distance x from a fixed origin as v is equals to a root x by x plus b. The dimensions of a and b with constant given. So we have to solve this based on the previous problem. So if you go to the next question, in the list 1 we have meter L, second S, kilogram M, Kelvin K. In the list 2 we are given with the different quantities. So for this we have to solve the first P option, HC by G. So we can write as HC by G whole to the power of, it is under root, so we can write power 1 by 2, which is equals to, H is dimensional formula for Planck constant, so m L2 t minus 1, and C is speed of light, so L t minus 1, and in the denominator G, so m minus 1 L3 t minus 2, because this is gravitational constant, so whole to the power of 1 by 2. So if you look at the numerator and denominator, we may have cancellation terms. So here L power 2 plus L power 1. So L power 2 into L power 1 means it will become L power 3 in the numerator, here L power 3 in the denominator, there it get cancelled. Now t power minus 1, t power minus 1, it will become t power minus 2 in the numerator, t power minus 2 in the denominator, it will get cancelled. So t power minus m power minus 1 will go to numerator, it will become m power 1 plus 1, so that is m power 2 whole power 1 by 2. This will become m. So for the first one, for P we get kilogram, that is m. So let us write P here, and if you see the next one, GH by C to the power of 5. So GH by C to the power of 5, it is also under root, so we can keep 1 by 2. Now the dimensional formula of G, that is m minus 1 L3 t minus 2, and H is Planck constant, so m L2 t minus 1. In the denominator C to the power of 5, C is speed of light, L t minus 1 whole to the power of 5 means L5 and t power minus 5 whole to the power of 1 by 2. Now again if you look at the numerator and denominator, we have L power 3, L power 2, so total L power 5 in the numerator, L power 5 in the denominator. So these two get cancelled. Now m power minus 1, m power plus 1, these two get cancelled. What left? T power minus 2, t power minus 1 in the numerator, so total t power minus 3 in the numerator. Now in the denominator also we have t power minus 5, when it go to the numerator, t power plus 5 whole to the power of 1 by 2. So if it becomes t power 2 whole power 1 by 2, that will be t. So in the question he is mentioned time second is as s. So if you see s, we are solved with that power t. So if you can change this option as a t, so q for this option. And next if you solve for the third one, k square L square C cube by GH. So k is Kelvin, k square, L is length, L square, C cube means C cube by GH whole to the power of 1 by 2. So this can be written as k square separate, L square separate, and C cube, so we can write L cube t power minus 3 in the numerator, and in the denominator G into H, where G is gravitational constant, m minus 1 L3 t power minus 2, and Planck constant m L2 t minus 1 whole to the power of 1 by 2. So if you again look k square as it is, now L power 2, L power 3, total L power 5 in the numerator, L power 3, L power 2, denominator L power 5, numerator L power 5 will get cancelled. Now t power minus 3 in the numerator, t power minus 2 minus 1, here also it get cancelled, t power minus 3 by t power minus 3. So what left? M power minus 1, m power plus 1, these two will get cancelled. So only k square left whole power 1 by 2. So this will be Kelvin. So for the third one we get Kelvin. So this will be our option R. And if you solve last one, you will get exactly the remaining option. But if you want to solve means GH by C cube whole to the power of 1 by 2. This will become G m minus 1 L3 t minus 2, and H is m L2 t minus 1, and in the denominator C cube, so L cube t power minus 3 whole to the power of 1 by 2. Here m minus 1, m plus 1, these two get cancelled. L power 3, L power 2, So here L power 3 will get cancelled, only L power 2 left. T power minus 2, T power minus 1, it will become T power minus 3. So T power minus 2 minus 1, here T power minus 3 will get cancelled. So what left? L power 2 whole power 1 by 2. So these two get cancelled. So answer is L. So if you look at the options, the L is matching with S. So option S, Q, P, R we can choose. S, Q, P, R. Option B is matching correctly. Here comes the practice question. Dimensions of universal gas constant in terms of Planck constant and mass time. LC are representing the physical quantities of inductance, capacitance and resistance. We have to find the dimensional formula ml2 t minus 4 a minus 2 corresponds to which of the following. So for that, the dimensional formulas of inductance, capacitance, resistance are given like this: ml2 t minus 2 a minus 2, and capacitance is m minus 1 l2 t l minus 2 t4 a2, and resistance is ml2 t minus 3 a minus 2. So first of all, I want to solve LC, because LC dimensions are very close and opposite. So LC dimensions of LC will be m L2 T minus 2 A minus 2, and next capacitance m minus 1 L minus 2 T4 A2. So if you see here, A minus 2 A plus 2 will get cancelled, T power L power 2 L power minus 2 will get cancelled, M power 1 M power minus 1 will cancel. Now what left? T power minus 2 T power 4, so it will become T square. So after solving this, I want to see the two options A and B in the denominator, LC there. So I'm going with the first option A. What do we get? R by under root LC. We have already solved the dimensions of LC. So in the numerator, resistance is there, M L2 T minus 3 A minus 2 divided by under root LC. So T square whole to the power of 1 by 2, because root is nothing but 1 by 2 power. So if these two get cancelled, what left? M L2 T minus 3 A minus 2, and in the denominator T power 1 there, when it go to the numerator it will become T power minus 1. So overall the dimension formula is M L2 T minus 4 A minus 2. So the given question is ML2 T minus 4 A minus 2. It is exactly matching with the first option. Without any delay we can choose the option A. If it is a multiple correct type question which is given in the JEE advanced type, there we have to choose for the other options, and we have to solve for other options also. So in this single correct answer type, we just have to select the single correct option ML2 T minus 4 A minus 2, which is corresponding to option A. So this is the way to solve the questions.